Hey everyone, I still can't see you. Right, okay. How was the party last night? I missed the party. I was just so tired yesterday, it's unbelievable. But I hear it was good, right? Well, awesome. Okay, so we're going to talk about Google Cloud Platform. And I'm going to get my water, which I conveniently left over here. And how many of you have heard of Google Cloud Platform? Oh my God, none of you. Oh, a few of you, okay. Well, you would have heard of Google Cloud Platform by the end of this talk. So you know who I am if you were here in my talk yesterday. And Twitter handle, please tweet me if you have any questions. Questions didn't go very well yesterday because I think I'm going deaf. So if you have any questions, please tweet them to me. So, Cloud Spin. The subtitle is How We Got All Matrixy in the Cloud. Do you remember that scene in The Matrix where she jumps in the air and the camera spins around her? That's what we're going to do here. Something like this. So we made this demo using Google Cloud Platform and 19 Nexus 6 smartphones like this one. And we're going to talk about the architecture behind the application, the back-end part of the application that actually made this work. And when we started thinking about developing and designing this, our engineers, our developer advocates came up with this technical diagram, lots of measurements and degrees, very technical diagram. And we gave this to our marketing people for a final design, and they came out with this, which is a little bit different, right? I think this looks much better. But this is what Cloud Spin looked like, our demo. And you can see we have a backdrop. We have 19 smartphones in a semicircle. We have a big X in the middle of the floor. And we would invite people to come up and jump, and we would take the picture of them. And we would do this at our events called Google Cloud Platform Next, which we ran across Europe and America and Japan. And what actually happens with this demo is that we invite people to sign up. They have to have a release if they want to share it on Twitter, the picture. But they would sign up via a tablet, and then they would step into the middle of the area. Somebody with a tablet making the whole application work, the whole demo work, would press a button, and that would send a signal to all of the phones and say, start recording the video. And at the same time, a countdown would begin. The person would be standing there, and we'd say 3, 2, 1, and then jump and press the button. Timing was quite interesting. You had to get the timing right. They would jump in the air, and we would send an audio tone to all of the phones. So a large beep, effectively. And that would effectively identify the frame in the video that we wanted to use for the final image. And it looks something like this. I won't use audio. This is my colleague, Ray. He's explaining what's happening. This is the phones. He's in the middle with an Android plush. Robert, my colleague, is driving it by the tablet. He will tell Ray to get ready and start the countdown. And 3, 2, 1, and then he would jump. At that point, the audio tone would go to the phones, and we would have identified the keyframe. Now, Ray's going to show the console, but we're going to skip out from there, and I'll show you that later. OK, we have a sizing issue. Why do we have that? OK, so let's talk about the architecture. The architecture is this. We're going to talk about this in detail, so don't worry about this diagram too much. Let's handle the first stage of the process, which is video uploads and notifications. We have to get these videos up from the phones to the cloud platform. And one of the things I'd like to think about is that let's consider this as being something we're going to do as a startup. So we may take this demonstration, make it into a box thing that we can install into malls, into train stations, and other public areas where people can walk up and get their 3D picture taken. So this could be a massively scalable effort. So we want to be able to scale this quite dramatically. So the first thing is that the devices, wherever they're located, will want to upload their videos to some place in the cloud. So we need some storage, an input bucket. And ultimately, the processing pipeline will extract the required frame and store that somewhere. And then the final image will be written to an output bucket. So we need some storage. And for this, we need large amounts of unstructured data to be stored. We're talking about megabytes, effectively, but it could be much larger. And again, if you think of the startup idea, we have lots and lots of requirements for storage. And we also have an immediate access to any data that's written to the storage system. We don't want it to be eventually consistent. We need it to be strongly consistent on reads. And we need to have notifications fired off somehow whenever a new video has arrived. So for this, we chose Google Cloud Storage. David mentioned this yesterday. Cloud storage is an object store, unstructured data. You can store pretty much any amount of data in cloud storage, terabytes per object, and all data is encrypted at rest. It's completely reliable and consistent, and it supports change notifications. The consistency, it supports strong read after write consistency on every object that's written to the bucket. And we support change notifications as well, along with things like versioning, object versioning, and resumable uploads and downloads. Cloud storage has a number of options which have developed over the years. The first is a standard storage system that has certain speed, availability, durability, and a cost point. This is universal cloud storage for pretty much anything. Then we have durable reduced availability, or DRA storage. And this is for cases where you don't really need high availability and high performance. And so in this case, the speed is a little bit less, the availability is a little bit less, the cost is dramatically less, and the durability is exactly the same. We will not lose your data regardless of which system we use. And the last one is nearline. Nearline storage offers a price point about half the price of DRA. And this is for infrequently accessed data that you won't have to access more than once a month. So it's more for disaster recovery and backup. It has less speed, same availability, same durability, but half the cost of DRA. And object change notifications are set up like this. So we have a cloud storage bucket, and we have an endpoint, an application that can receive webhooks, parameterized URLs. And what we need to do is wire the two up. So we can use a simple command, gsutil notification watch bucket, with the endpoint of the app that's going to receive the notification, and the input bucket. We can wire them up together, and then now whenever a client adds, removes, or updates an object within that bucket, a notification request will be fired off to the endpoint. And that will include lots of metadata about the image that's changed or been removed. And that will include the URL of the object. So this is an example of a change notification. You'll be able to see this in the slides when I share them later. And cloud storage also has edge caching. Lots of data passes through the edge of our network. And if it has cache control headers set on it, we can cache it for a period of time. And we have points of presence near in pretty much every major city in the world. So this means you can cache your data very close to the user. All you have to do is set cache control headers when you actually store the data in cloud storage. So this is the summary. I'm going to skip over this because we don't have much time. So the next one, so videos have been uploaded. That's what a video looks like. We can quickly play that. I can't do the audio. I haven't got the audio hooked up. But if we did have the audio hooked up, you'll hear the beep that we send to each of the phones. So that's how we record the video and identify the key frame. Right, so next one is notification processing. And so the input bucket will fire off an object notification every time a new object is stored, a new video is stored in this case, and that will go to the notification processor. What does that do? We need it to be able to handle HTTPS post requests, effectively webhooks. We also need simple authentication. We want this only to be accessible from within the application. We don't want other people to be able to upload videos and do other strange things to this endpoint. So this should be only exception requests from the cloud storage bucket. And we also need it to be able to process anything that comes in and push tasks onto a queue somewhere or onto a topic. And so we chose Google App Engine. How many of you have heard of Google App Engine? Yay. OK, more of you. Cool. So Google App Engine is a traditionally platform as a service offering where you don't have to worry about building software stacks. We support Java, Python, Go, and PHP with the older system. And with the newer system, we support Node.js, which is in beta currently, and also custom runtimes, your own runtimes. Basically, you provide a Docker file, and we can run that for you. And the key point here is that we build and manage the software stack for you, unless you provide a Docker file, in which case you have some kind of involvement there. You can build and test everything locally. We have a local development environment. Really allows you to focus on developing application code, not having to worry about managing environments and infrastructure. It supports versioning, it supports traffic splitting. And one of the most important things is the whole thing is fully managed for you. We do all of the management, we do all of the patching and upgrading of the system. It's supported 24/7 by Google SREs, site reliability engineers. And it has best-of-breed autoscale. This thing can autoscale. This is why Snapchat and people like that use it. And Snapchat are massive on App Engine, really massive. And in terms of the languages we support, I mentioned Go, PHP, Python, and Java 7. That's on the App Engine sandbox hosting environment. We provide a sandbox runtime that can scale very, very rapidly, very quickly, up and down. And the sandbox kind of limits you in what you can do. And to get around that, we've introduced a VM-based hosting environment, which is often called managed VMs. We're trying to get away from that name. This basically runs your application within a Docker container, and it allows you to run pretty much any code you want to. So in summary, the application that we wrote for this was a Go-based application run on Google App Engine, and that would receive requests. The requests come in from any objects that were stored in the input bucket. So now we need to talk about messaging and pipelines. We need to do the processing on these uploaded videos. And for this, we have a long pipeline, which we'll go into the details of now. And for this, what we need to be able to support is asynchronous messaging. We don't want this to be synchronous. We want it to be done all asynchronously, which gives us a few more headaches, but we'll worry about them later. The next one is we need to support pull subscriptions. Now, given the startup idea where we may have to scale this to many, many, many iterations of the demo across the world, we want to be able to scale dynamically rather than having a fixed pool of workers. And in the case where we're scaling dynamically, we can't really register them ahead of time as push subscribers. So they need to be able to go to a message topic or a queue and pull work off of the queue themselves when they wake up or when they're not busy. So they need to support pull subscriptions. So for this, we chose to use Google Cloud PubSub. PubSub is a messaging system. I'm not going to spend much time on it today, but it's basically our internal messaging system that's built into our infrastructure. So for this, you don't have to spin up RabbitMQ or some other queuing system. This is built into our infrastructure, and it will scale dynamically to meet your needs. And it basically provides real-time, many-to-many, it doesn't have to be many-to-many, asynchronous messaging between applications. And that's pretty much all I'm going to say about it. But if you're interested to hear more about PubSub, let me know. And, well, I'm going to have a couple more slides just to show you how it works. But if you have any more questions, ask me later. And basically, we have the idea that publishers will publish to topics. They will send messages to topics. And we will create subscriptions, and then subscribers will either pull messages from the topics or will be pushed messages from the topics. Publishers can be pretty much anything that can talk to googleapis.com, can send messages to googleapis.com. And subscribers can be, again, the same, or anything that has a webhook, anything that can expose a webhook, like our notification processor earlier. In our case, we had 3 use cases for messaging. One was log extraction, which we're not going to talk about. The next one was frame extraction. So we need to get these videos, and we need to extract the appropriate frame from each one of the videos. And for this, we'll be pushing messages onto an extract topic. This is from the notification processor. Then the extractors will go and pull messages from that topic and process the video appropriately. And this is what a frame extracted looks like. And here's 5 frames from a series. There will be 19 in the end. Then we have the stitching topic. The stitching topic will be fed by extractors. So we will have extractors publishing to the topic. This is where we've extracted the frame, and now the stitcher needs to actually pull those frames together. So it needs to know where they are. And the stitcher will receive push notifications from the stitch topic, telling it that new messages have arrived. And we'll look at the details behind that shortly. And this is what we end up with. We end up with a cloud spin image. So in terms of processing on the pipeline, we have a need for a long-running service with on-demand scaling of those workers that are servicing those topics. And we really want to be able to scale on queue depth being massively important in this case. And we need it to be able to act as a very secure pub sub-subscriber. So again, we don't want anything else subscribing to these topics, just these extractors and stitchers. And it needs to be ultimately simple to develop, deploy, and manage. For this, we chose Google Compute Engine. And Compute Engine is effectively virtual machines in the cloud. And we have many, many different types of virtual machine. We have zones, regions. We have 2 regions in the US, East and Central. The East one was introduced recently. We have a region in Europe and a region in Asia. We have fast software-defined networking as a backbone. It's very cost effective. We don't charge by the hour for our virtual machines. We charge by the minute. You pay for the first 10 minutes, but then you'll build incrementally per minute after that, which is much cheaper than many options. We also don't charge for IOPS on our persistent disk. We do charge in a way by charging you for, or by limiting IOPS based on the size of the disk, but it's completely deterministic. You know exactly what you will be charged for IOPS. You also get sustained usage discounts over the month, so you can save up to like 40–50% if you use a particular virtual machine type across the entire month. Not one specific instance, but one specific type. It also is quite innovative. It supports live migration, so when we do maintenance on a zone, we actually move your virtual machines and your disks without you even noticing. You'll see a message in the log, but that's pretty much all. We also have preemptible virtual machines. These are low-priority virtual machines that are perfectly suited for batch jobs, but are pretty much half the price of the standard virtual machines. And we also support SSD and very, very fast locally attached SSD as well. So if you have a very strong requirement for high IOPS, we can do local SSD, which is directly attached to the CPU that's writing and reading to them. We have many different types of instances, up to 32 cores, 208 gigabytes of RAM, many, many different operating systems, including Windows, which is extremely popular on our platform, believe it or not. Really is. It's extremely popular. Then we have this idea of instance groups. And basically an instance group is a grouping of machines that are completely identical, completely homogeneous. And what that gives us the ability to do is to provision them from a single template and also to auto-scale them dynamically. And we saw that auto-scaling was one of the requirements of our app. So let's talk about auto-scaling. So we have this managed instance group, which is a group of identical virtual machines, and we can monitor that. Based on certain signals, we can auto-scale. We can scale up or we can scale down based on certain signals. We can look at average CPU utilization over time. We can look at requests. We can plug these things into a load balancer and base our auto-scaling on requests per second or on service utilization. And we can also plug into metrics such provided by our cloud monitoring, which can monitor every aspect of a virtual machine effectively. Disk throughput, memory, everything. So we can auto-scale on many, many different signals. And we also support custom metrics. And custom metrics allow you to define your own metric that you care about and scale based on that metric. Providing you can scale proportionally based on that metric, it's useful. So in this case, we show on the diagram, we're looking at a pub subtopic. So the number of messages on the pub subtopic will determine how many workers we need. And so we can auto-scale based on the number that there are on that topic. Scale up and scale down. We also looked at containerization for this. Effectively, what the architecture could be is something very, very similar, where we just run Docker containers on CoreOS instances or any other instance that would support Docker. But ultimately, we could replace this with something like Kubernetes, which we talked about yesterday. So that's a summary of where we are so far. We have the stitcher and the extractor. They do all of the compute work. The extractor will extract the frames from the videos, and the stitcher will stitch the frames together to create the final image. So The one thing about that, though, is that because it's all asynchronous, we need to have something to coordinate the whole system together. How do we know when all of the videos have been processed, all of the frames extracted, when the final image has been stitched together? So for this, what we can do is, with our extractors, we will extract the frame, store it in temporary storage, and then write a message to an online database. We'll just say, this is the ID of the frame and the image that we're processing, and we're finished, we're ready. And that will then fire off a message to a stitch queue, and the stitcher will wait for the appropriate images to arrive. And it will carry on checking in the online database to see if all of the images are there, all of them. Once all of them are there, it will say, OK, I have all of the images I need. I can now retrieve the images and stitch them together. And so the key here is the online database. Our requirements for that are, we need a cloud-based storage system. We need to not have to worry about server-side coding. We've already written this application. We don't have to worry about writing more code. So we want to keep it as simple as possible. And we want to be able to push updates to clients in real time. So we don't want delays in this system holding up the whole processing. So for this, we chose Firebase. And how many of you have heard of Firebase? OK, not many of you. OK, interesting. So Firebase is effectively a NoSQL JSON database in the cloud. You can access this directly from clients. So you write application code on your Android device, iOS, web. We provide client libraries that handle all of the details behind the scenes for you. And ultimately, whenever any updates are made to an application, updates are pushed out to Firebase immediately. And anybody who's registered and interested in those updates will receive updates from Firebase in milliseconds. It's extremely fast and extremely effective. NoSQL JSON, basically a nested object we store, very similar to MongoDB. You can effectively take your MongoDB, dump it to a JSON file, and then import it into Firebase. It has a strong security model, which allows direct access from the client devices and from nowhere else. And it also maps each piece of data to a URL. So it's extremely effective. And I wish I could talk more about it, but I think somebody's already given a talk about Firebase, maybe yesterday or maybe today, not sure. So let's do a quick demo of how this works. So this is the Firebase debugger. It's called Forge. And basically, this is where we go to monitor what's happening with Firebase. This is effectively our nested JSON structure. And we have cameras, we have sessions, we have settings. The settings for the whole thing are there. And this is where all of the data is stored for the whole of Cloud Spin, the metadata stuff. And what we need to be able to do is go to our instance. And this is a virtual machine that we have running in the cloud. Make that a little bit better. OK, that's better. And so what we can do is we can actually emulate the whole process. And this is the Cloud Spin dashboard. So basically, this is what Ray was going to be showing you. And it has the pipeline at the top there. So we have a camera, we have an input bucket, we have the extractor, the stitcher, and the output bucket. I'll quickly zoom in on those. Something's gone wrong with the UI there. I don't know why. Oh, right, OK. Doesn't size very well. OK. That's quite often the case. Oops, OK. Right. So here we have 18 phones in this case. What we're going to do is we're going to simulate uploading the videos from the phones by copying them over from our virtual machine. And to do this, I need to do all of the setup. I think I've done that. So I'm just going to do a copy. So I'm going to use a tool called GSUtil, which is a tool for our Google Cloud Storage. And we're going to copy a bunch of videos over to a cloud storage bucket. The path at the end is the cloud storage bucket URL. And what we can do is copy them over. And that was a parallel copy. They're quite large videos. We copied them all over in parallel. And then we can refresh this. Oh no, we don't need to refresh this. And now we'll see the images will start appearing. This is easily the extracted images, extracted by the extractor. And they're appearing one by one. We have 18 in total, so we can see each image is different because they're taken from a different phone in a different position. This is my colleague Brett from New York, by the way. And ultimately, we have 3 more, 2 more. You can tell this is asynchronous, right? And we're finished, and ultimately, then the stitcher gets to work and we'll stitch the image together and write it to the output bucket, and that's it. That's how it works, okay? We didn't see much about what happened in Firebase, so let me just show you something in Firebase. So to do all of this setup, I have to actually reset the system, and what we can do is look at how that works in terms of the Firebase console. So the first one is to reset the system. And I have a Node.js command to do this. It's basically a Node script that we wrote just for this demo, and we're going to do a reset for it. And that will reset Firebase. And you can see Firebase being updated. That's just updated the status of the cameras. The next one is to do a -f, which will make the cameras ready. I think we can actually go and look at this now. We'll see they're ready now. And we'll do F. OK, I didn't do what I expected. Oh, right, OK, next one will. And the last one is to do U, which is to make them ready for uploading. And you can see they all changed immediately. So that was happening over a direct connection to Firebase, and, well, not a direct connection, an internet connection. And, OK, so that's the demo. That's how Cloud Spin works. And in order just to quickly wrap up, in the future, we talked about Kubernetes and we talked about Container Engine yesterday. Well, we didn't because I ran out of time, but basically, we could have used Kubernetes for this, and Kubernetes has something called Container Engine, which is our implementation, our productized version of Kubernetes, which you can get from Google Cloud Platform. With that, we manage the host for you, the master for you. You don't have to worry about managing the master, just the nodes. So a wrap up, a hex test. We have all of these hexagons in Google Cloud Platform, and this is one of them. This is Google Cloud Storage. This is App Engine. We talked about App Engine, notification processing. This is Cloud Pub Sub. It's very hard to remember all of these. We have so many, it's unbelievable. So if you want to test me later, bring me some hexes and show me them, and I'll see if I can tell you what they are. This one is Cloud Pub Sub. This one is Google Container Engine. This one is Google Compute Engine. And that one is Firebase. So that's good. These are the people who built Cloud Spin for us. It's Brett, Frances, Kathy, and Ray. If you go at Google Cloud Spin on Twitter, you'll be able to see all of the images that we've processed over the years. And I'll just quickly show you that. So at Google Cloud Spin, you'll find many examples of this done using our big rig and also our small rig as well. And so there's some of the guys. It looks quite incredible. We're getting better and better at doing this as we go forward. So last slide. So basically, we showed you some of the aspects of Google Cloud Platform today, but there's much, much more to it. We have things coming on all the time. We have recently introduced something called Dataproc, which effectively allows you to manage Hadoop clusters and Spark clusters in the cloud. We also have something called Data Lab, which allows you to interact with IPython using Google BigQuery to do interactions. And that was released in the last couple of weeks. We have many, many different services coming along all of the time. And effectively, we feel we're getting close to having a complete set of services now for building, developing, hosting applications. We really do have the leading infrastructure of any cloud provider. That's a given because we run things like Gmail, we run things like YouTube and Cloud Search on the same infrastructure that we run Google Cloud Platform. So you can guarantee that this is a best-of-breed infrastructure. And also, our platform is innovating quite dramatically. We still having to do a lot of work to keep up with Amazon and Microsoft, but they're doing great work as well. And if you've not migrated to the cloud yet, it doesn't really matter which provider you use. I'd love you to use Google Cloud Platform, but you could choose any cloud provider. But you should really consider looking at moving to the cloud as soon as possible. It will ultimately save you money, it will reduce your development times, and it will give you better services for your customers. And so that's it, basically. Thank you very much for coming. I appreciate it. Thanks. If you have any questions.
Yeah. What about questions? By the way, we have 14 minutes.
And basically, I have some stickers. So if anybody didn't get stickers earlier, I have stickers you can have, Google Cloud Platform stickers for your laptop, or you can stick them on your head and wear them if you like this. If you do, I'll probably give you an extra prize. I don't think I've got an extra prize, but we could do. Right, questions?
Yeah. Any questions, guys? Okay, I will try, because I have a question, and then we ask. Oh, Freddie, okay. You want to?
You talked about how using scaling in cloud compute.
Yeah.
And is it possible to do that with Kubernetes, how you talked about yesterday?
Yeah, go on.
Because you seem to say it's not possible with Kubernetes yesterday.
Right, so I think Kubernetes needs to do the scaling. It needs to send the signals to the infrastructure to do the scaling, say, hey, I need more nodes. So what we need to do is first solve that problem. There are some, if you go to the Kubernetes GitHub, there are some issues already in process talking about that. Some of our guys in Poland have been working on this already. But the whole idea is we have to scale the pods first. When we scale pods, we have more nodes. At that point, Kubernetes has to say to the infrastructure, hey guys, we need more nodes. Now for this scaling system, it may be we just put a message on a queue somewhere to say, monitor this. If this changes, add more nodes. But it's a little bit more complicated than just scaling up. But ultimately, it will be here, and it will use this on Google Cloud Platform. But it will use something different on Microsoft, something different on Amazon, something different on Mesosphere. Okay? Cheers.
You can say on the left side, or for you it's right side, and there is no lighting, no such more lighting, so probably try to the right side stay. Just here, no, here.
What do you mean?
Or you wanna, because you hiding from lightings, and if you can start, is it better?
Oh, it is better, yeah.
Oh.
But the camera can't see me. I checked on the camera, it couldn't see me. Hey, there's people out there. That's awesome. There's a question over there.
Hi.
Oh, hey.
So it seems like Google App Engine and Cloud Platform, they use lots of Google-specific technologies. Would it be easy to migrate to another platform if you really want to, like Amazon Web Services or Microsoft Azure?
That's a great question. So really the question is whether you can migrate. Once you've chosen to use Google Cloud Platform, could you, if you decided you didn't like it, migrate? So with App Engine, there's something called App Scale. App Scale is basically App Engine 1.9, a little bit older than our version, but they've taken it and they've boxed it up, and you can run it on EC2. You can run it on Amazon. You can run it on premise. So you can run your App Engine applications using App Scale anywhere, not just on Google Cloud Platform. So that's really good. With the new hosting environment, that will be Docker-based. So you'll just have a Docker file or a Docker image. So ultimately, you can just take your Docker image and run it anywhere that will support Docker. That's a new one. With virtual machines, pretty much you're just running a software stack, your own software stack. So you can move that wherever you want to. So that's really easy. You're not locked in with virtual machines at all. Just take your code, move it off to Amazon or whatever, that'll be fine. The biggest problem is data. Once you've stored terabytes of data into a cloud service provider, it's very hard to move it because it takes a lot of time. It's possible, but it just takes more time. So you need to probably think about data first, where you will store your data, and then work out your strategies based on that. Ultimately, one day you'll be able to store data across all 3 cloud providers. Really, that's going to happen one day. And one day we'll have multi-cloud environments to support Amazon, Google, and Microsoft, and have an abstraction layer on the top of it, and you won't really care about the cloud provider that's used. Maybe you'll go for the cheapest option or the most performant option, but that's what's going to happen ultimately. We want you to move to the cloud, and we want our cloud to be the best possible cloud. If it's not, then use somebody else's. If it isn't, please feel free to email me. get my card off me, and I'll try my best to get your questions answered. Yeah, but don't ever despair about using it. You can always move whenever you need to. Hey, right.
Okay, you say there was a question, yes? Or no?
There was a question there, this guy there. Hey, do you
Yeah.
have a question still? No, there's one behind you.
But they didn't raise a hand.
They did. You didn't see it.
Okay, so we all knew that real values we can get when we comparing. So could you please make a comparison and name some advantages or maybe even disadvantages comparing to other popular solutions in cloud services?
Yeah, I don't normally do this. It's really up to you to make your mind up about which one's better. I think from our perspective, Google App Engine is the best platform as a service offering out there. It's not the most flexible, but it's the best in terms of scaling. So if you have to scale dynamically, App Engine's the only solution. Some people who have used App Engine could not have done what they did on any other platform. Even if they built it themselves, they could not have done what they did. So App Engine has got huge advantages when it comes to autoscale. When it comes to doing anything else, if you want to run virtual machines and you're using persistent disk storage systems, then we have good consistency, very high levels of consistency. Remember, again, this is the infrastructure we use to run Google Cloud Platform, to run our stuff, Gmail and Search and YouTube. So we do everything we can to eliminate the idea that one process will affect another. So with some cloud providers, you may find that what somebody else is doing may impact your performance. They may be accessing disk, and your disk performance may go down because of that. So I think consistency is extremely important, and we are very, very consistent. With virtual machines, again, we have very, very quick spin-up times. You can spin up 1,000 virtual machines on our system. We've done this demo before in about 2 minutes. You can spin up one virtual machine in about 30 seconds. We do all this in parallel. So if you want to be able to dynamically scale your services, then I think really Google Cloud Platform is the best option. And I think also, if I was from Amazon, I could talk about lots of good things that Amazon has that we don't have. But I'm not going to, because I don't work for Amazon. So, but I think we have really good advantages over the other services, but I think you really also need to check all of them out and make your own decision. I think we have a really good platform, but really, I only care about you thinking that we have a really good platform. So please try it out and feedback to us and let us know. Because it's basically listening to developers and doing things like this that will make our platform better. So if you say you use it and find problems, if you don't tell us about it, we can't fix them. So, okay, does that answer your question?
Any questions? Okay, I see.
Any other questions?
Yeah. There's one.
Hello. So the question is, like, as far as I know, Microsoft is moving forward towards supporting Docker for Windows Server. So the question is, are there plans in Google to start supporting C#, for example, in App Engine?
Well, I think the key here is, well, I think the question really becomes, will we ever support Windows with App Engine as opposed to C#? Because Mono is getting better and better, so the ability to run C# on Linux is becoming easier and easier as Mono develops. Again, I'm only hearing that secondhand. I don't have any specific experience of that. But I think with the container-based, VM-based hosting environment on App Engine, you'll be able to run Mono very easily. So if you have a Mono application, you'll be able to stand it up on a virtual machine, effectively managed by App Engine. So I think that will work straight out of the box. But if you're talking about running C# on .NET on Windows with App Engine, that's probably a lot further away. It may be something that's impractical for us to do, but it's possible we may look at it one day. But I think your best option now is to run Mono on App Engine, what used to be called managed VMs, and then maybe talk to us about what we need to do to support your needs in the future when it comes to C# development. We're always listening, so we're definitely interested in implementing things that developers are interested in implementing. Does that answer your question? I'm not sure. Yeah? Okay. A little bit fuzzy, but yeah, Mono is the best option, I think.
Okay, any other questions? Okay,
There's
I will. I
there's
will.
one there. Just
Okay.
one quick one.
App Engine now supports the Python 2. Is there any plans to support Python 3?
So again, the VM-based hosting environment will support Python 3 now with custom runtimes, so you can build your own Python 3 stack. In the next iteration of that, then we will have a Python 3 runtime, yeah. But it won't be the native, the older sandbox environment, it'll be the new environment, which are kind of different. You need to check out both and make up your minds about them. But yeah, we will support Python 3 in the new version that's coming up. Yeah, thanks.
Freddy, again.
How does the custom App Engine environment differ in terms of pricing and scaling and speed and stuff like that?
Good question. So how does, I think everybody heard that question. So in terms of speed, we have some things we need to work on. We're still working on them, still in development, it's still in beta currently. At the moment, the development experience is pretty good, but it can be slow to build the images. We have an image building service that we have that does all of your image building in the cloud. At the moment, what we're doing is spinning up a virtual machine to build the image for you. In the future, we'll have a service that's up and running all of the time to build your images, which will reduce the uptime very dramatically. Performance will be very good. And again, you can scale, you can have different machines, different size machines as needed. So if you need a 64-core machine, you can use that. In terms of auto-scaling, it uses the autoscaler. So it's going to be different from what you have with the sandbox version of App Engine. It's still going to be pretty good compared to other cloud providers, but not as good as the older App Engine. And also at the moment, we can't scale to 0. With the older App Engine, we can scale to 0, but with the newer one, currently we can't scale to 0. So you always have one virtual machine. So that's a bit more in terms of cost. But we're working on that and looking at ways we can get rid of that as well. In terms of pricing, we haven't really settled on the pricing at the moment. So at the moment, you're paying for a virtual machine or for the virtual machines you have. I think ultimately it's going to be very competitive with the sandbox environment. Okay? Right, okay.
What about Dart support?
Dart support. Again, you're talking about App Engine or Google Cloud Platform generally?
In general.
So with virtual machines, no problem at all. We support Dart. We support the ability to run Dart on virtual machines using App Engine as well. Pretty much all I can tell you at the moment. We don't have a runtime for Dart. And we were hoping we would have one, but we don't have one currently. Okay? All right, I think we're out of time, aren't we?
1 minute.
1 minute, wow. Okay, well, good. Thank you, guys. Thank you for listening. Appreciate it.
Thanks, Mandy.